review. Finding slope. Okay, remember that anytime that you have y equals a number, you're going to have a horizontal line and the slope is automatically 0. Now you can also think of it as y equals mx plus b, and this part right here is missing, so that slope would have been 0. This one, the slope on this is positive. How far up did I go? How far over did I go? I went up 1, 2, 3. I went over 1, 2, 3, 4. So 3/4. Here, my slope is y2 minus y1 over x2 minus x1. I really just did that. x2, y2. So 5 minus 4. 3 minus negative 2, it's going to be 1 over 5. Okay, this is a vertical line. That means the slope is undefined. Okay, slope on this one, y2 minus y1. x2 minus x1, x1, y1, x2, y2. So that would get me 12 minus 5 over negative 6 minus negative 6. That would get me 7 over 0, which is undefined. There's an easier way to look at this. Both of these x's are exactly the same. That means that you would have a vertical line. Here, again, y2 minus y1, x2 minus x1, x1, y1, x2, y2. So, negative 3 minus a negative 3 over 12 minus 11 gets me 0 over 1, which is 0. Okay. Sorry about that. So Mr. Smith is draining his pool to have it cleaned. At 8 a.m. it is 2,000. It had 2,000 gallons of water, and at 8 or 11 a.m. it has 500 gallons. What is the rate of change in the amount of water at the pool? So we started at 0 hour and we had 2,000 gallons. 3 hours later, we had 500 gallons. So 2,000 minus 500 over 0 minus 3. So that's going to get 150 over negative 3. So negative 50 is my slope. We don't want to just say, because this is a word problem, we want it to have not just negative 50. We would say the pool drained, because that takes care of the negative part, drained 50 gallons per hour. Okay, so now we're going to be doing the same thing. I'm going to change colors though. We're going to do the same thing, except for we're going to put in a variable in here. So this would be x1, y1, x2, y2. So we're going to replace the m with 3/4. R minus 5 over negative 3 minus 3. So that would get me 3/4 equals r minus 5 over negative 6. Then I'm going to multiply across. I'm going to get 3 times negative 6 equals 4 times r minus 5. Negative 18 equals 4r minus 20. Add 20 to both sides. Get 2 is equal to 4r. Divide by 4 and get 1/2 is equal to r. Okay, next, we're going to do the same thing. This is x1, y1, x2, y2. Our slope is y2 minus y1 over x2 minus x1. So 2 equals 9 minus 3 over 5 minus r. Remember, that's over 1. So 2 over 1 equals 6 over 5 minus r. Multiply this direction, I get 2 times 5 minus r. Multiply this direction, and I get 6. So 10 minus 2r equals 6. Subtract 10 from both sides. Get negative 4. Divide by negative 2. And get r equals 2. Okay, next one. So again, x1, y1, x2, y2. We have y2 minus y1 over x2 minus x1. So 1/2 equals 3 minus 2 over 6 minus r. So 1/2 equals 1 over 6 minus r. Multiply, I get 6 minus r. Multiply, I get 2. Subtract 6 from both sides, get negative r equals negative 4. Divide by negative 1, and r equals positive 4. Okay. Slope-intercept. That means I'm in it in y equals mx plus b form. So I'm going to add 10x to both sides. 2y equals 10x plus 12. Divide everything by 2. Y equals 5x plus 6. Okay, again, negative 6, negative 6x. Bring down my negative 3y. Make sure you bring that negative down with it. Oops, that's a horrible 8. Okay, divide everything by negative 3. And y equals 2x plus 6. Okay, so next I have a teacher buys 100 pencils to keep in our classroom at the beginning of the school year. She allows the student, so this is what she starts with. She starts on day 1 with 100 pencils. She allows the students to borrow pencils, but they are not always returned. On average, she loses about 8 pencils a month. So loses 8 pencils per month. Okay, so write this in slope-intercept form. So our slope is negative 8. Our y-intercept is 100. The dentist. Okay, the equation 2y equals 4,692x plus 324,836 can be used to estimate the number of active dentists in the United States from 2001 to 2015, where x is the number of years since 2001, y is the number of active dentists. Rewrite it in slope-intercept. So 2y equals 4692 x plus 324,836. Divide everything by 2. Get y equals, that's 2346x plus 162418. Okay, the slope of this, that means, oh, sorry, that's the equation. The number of active dentists increased by per year. So that means that's the slope, 2,346. In 2001, that's the year we started. How many did we start with? 162,418 active dentists. Okay, so now we're going to do x and y intercepts. So that means I'm going to plug in 0 for x. So if I plug in 0 for x, it's going to get me negative 2y equals 4. Divide by negative 2. Get y equals negative 2. Then I'm going to plug in 0 for y. So negative x minus 2 times 0 equals 4. So that's negative x equals 4. Divide by negative 1. get x equals negative 4. So now I can graph this. So 0, negative 2, and negative 4, 0. Oh, and I'm not going to be very good at drawing this. Yeah, that was horrible. Little better. There we go. Okay, so this one, I'm going to do the exact same thing. Plug in 0 for x. If I do that, I get 2y plus 12. Divide by 2 and get y equals 6. Plug in 0 for y. I would get 3x equals 12. Divide by 3, get x equals 4. So I'm going to plot the point 0, 6. Plot the point 4, 0. And maybe I can do this. There we go. Looks pretty good. Then, last but not least, plug in 0 for x. I get negative 8y equals 24. Divide by negative 8 and get y equals negative 4. Plug in 0 for y. I get 4x equals 24. X equals 6. So 0, negative 4, and 6, 0. No, not quite. No, it's better. It's not perfect, but it's better. Okay, graph using slope-intercept. This is my y-intercept, so I plot this. My slope is negative 3 over 1. Remember, that goes this direction. So I'm going to go down 3, 1, 2, 3 over 1. 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 Now, could I have gone up? Yes. 2, 3, but to the left. 1, 2, 3, and to the left. Okay. This next one is not in slope-intercept form, so we need to put it into slope-intercept form before we can do anything. So we subtract 3x from both sides, get negative 2y equals negative 3x plus 8. Divide by negative 2, divide by negative 2, and divide by negative 2. Y equals 3 over 2x minus 4. So I'm going to plot my 0, negative 4, and then my slope is going to go up 3 and to the right 2. So 1, 2, 3 over 2. 1, 2, 3 over 2. 1, 2, 3 over 2. 3 over 2. 1, 2, 3 over 2. Could I have gone down 1, 2, 3 and to the left 2? Sure. 2, 3 over to the left 2. And voila. Okay, on this one, subtract 4x from both sides, get 3y equals negative 4x plus 9. Divide by 3, divide by 3, divide by 3, and get y equals negative 4 thirds x plus 3. So I'm going to plot my 3. This is a negative slope, so we're going to be going this way. If I go up 4, 1, 2, 3, 4, I have to make sure I go to the left 3. 1, 2, 3, 4 to the left. 1, 2, 3. Go down 4, 1, 2, 3, 4 over 3. 1, 2, 3, 4, 1, 2, 3. And voila. It's not liking what I did, so let's do it this way. That's better. It's not perfect, but it's better. Okay, so this one, I don't like fractions. I'm going to multiply by 2. 3y plus 2x equals 12. Subtract, nope, not even going to do that. Subtract 2x from both sides. Get 3y equals negative 2x plus 12. divide by 3. Y equals negative 2/3 x plus 4. So 4, I have a slope of negative 2, so 1, 2, 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, 1, 2, 3, or 1, 2, 1, 2, 3. 1, 2, 3. Okay, either way direction would have gotten you the same line. Okay, is it linear or not? Well, it has to have a constant rate of change. So this went down by 7, down by 7, down by 7. This went down by 3, down by 3, not down by 3. So that went down by 9. So we would have negative 7 over 3, negative 7 over 3, and negative 7 over 9. So that is a no, it is not linear. They do no constant rate of change. Okay, this next one. This went down by 1, down by 1, down by 1. This one went up by 8, up by 8, up by 8. This is negative 1 over 8, negative 1 over 8, negative 1 over 8. So, yes, the slope is negative 1 over 8. And this one, oh no, let's do red. This went up by 3, up by 3, up by 6. This went down by 2, down by 2, down by 4. 3 over negative 2, 3 over negative 2, 6 over negative 4, which goes down to, so yes, because the slope is negative 3 over 2. Okay, awesome. Piecewise. David earns $9 per hour for his job for the first 40 hours he works a week. However, he is paid increases to $13.50 per hour thereafter. So for a certain amount of time, he gets paid one amount, and then after that, he gets paid more. So we need to figure out how much that is. So when X is less than or equal to 40, he makes, hold on, it's not being nice to me. He makes $9 per hour. Okay, so we have to take 9 and multiply it by 30. And we should get 270. And by 40, 360. But when it's greater than but greater than 40, he gets paid $13.50. So I'm going to take $13.50, multiply that by 50, and I get $675. Okay, so we're going to graph the function here. Maybe. It's not going to be perfect, but that's okay. So we're going to put hours worked down here. And I'm going to do 5, 10, 15, 20, 25, 30, 35, 40, 45, and 50. That's what we went up to is 50, yes. Okay? So he's at a constant rate of $9 per hour for that first amount. And then he goes up. So let's see, what do we want to go up by on this over here? Maybe we'll go up by 50s. 50, 100, 150. I know I haven't labeled. Ooh, that was horrible. I shouldn't go that far up. 150, 200, 250, 300. I know I should have put one here for you, but that's okay. 450, 500, 550, 600, 650, 700. And that is money earned, and that's dollars. So at 0 hours, he made zero amount of money. At 30 hours, he made 270. So 30 is 270. So somewhere right in here. And at 40, he made 360. So 40, he made 360, somewhere here. So from here to here, it's not perfect, guys. He made that. But after 40, now, I didn't talk about this. We need to see, because if he worked 40 hours in 5 minutes, he still gets paid more. So here at 40, I actually need to know how much it would be at $13.50. So let's put in 40. That's $5.40. Now he's not going to actually make that, so we need an open dot at that. So at 40, $5.40, he's going to have an open dot. And at 50, he's going to have $6.75. So about here. And that's what that's going to look like. Okay, so here we have a piecewise. I'm going to give you a hint on this. Isn't this slope intercept? That is the y-intercept. So this is 4. And that would be 1, 2, 3 over 1, or it would be down 1, 2, 3 over 1, right? That's what it would be. But this says when it's greater than or equal to 1. So I have to start here at 1. So 1, 2, 3 over 1. So it's starting here at 1. It is not going to include these points down below, but you can use that to actually graph it. Then this one says I have a y-intercept of 3 and I have a slope of 1. Okay, but at 1, it needs to be an open dot. So I'm going to change this. Oops, I didn't mean to erase both of them. To an open dot. Or you can make a table. So over here, at 2, I have a slope of 3. 1, 2, 3 over 1. 2, 3 over 1. 1, 2, 3 over 1. Now this is going to be an open dot because at -1, it needs to be an open dot. Okay, and then this one can be a closed dot at -1. Okay, so -3. Now, guys, this is one that's not going to count. I have to go down 1 over 2. Oh, up 1 over 2. Okay, so I want it to be -1. So it's going to be, I need to know how much of this is going to be at -1. So that's going to be 1/2 minus 3. So that's -2.5. So at -1, we're at 2.5. To -2.5. So this is going to be a closed dot here. These dots can't exist, or it's not even a function anymore. And then we're going to go up 1 over 2, up 1 over 2, just so that I can get a prettier picture out of this. Oh, you know what? This has to be an open dot, and I totally made it into a closed dot. Oh no, it's a closed dot. I lied. That's a closed dot on this side. It's an open dot on the other side. Okay, there we go. So over here, it's going to be at -2. So if you would like, you can always do this too. You can always say, oops, that's not -2. This is -2. So at that line right there is where it's going to change. So I'm going to do 1. This is going to be down 2 over 1, down 2. This is going to be an open dot, down 2 over 1, down 2 over 1, down 2 over 1, over 1. And these points are not existing. So it's this right here. And then this part right here, -1. So this is down 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. And there we go. Okay, true or false? Arithmetic sequence may have a common multiple. No, that's false. It's a common difference. Okay, determine the next 3 terms. This one up by 7, up by 7, up by 7. So if this goes up by 7, it's 31, 38, 45. Okay, so this one, what is the common difference? This goes up by 0.5, 0.5. So a sub n equals a sub 1 plus d times n minus 1. So a sub n equals -2. I don't know why I put a comma. Plus 0.5 n minus 1. Now, if we were just leaving it in this form, that's perfectly fine. I would say simplify it. So a sub n equals -2.5 plus 0.5 n. And normally you have it in descending order, so you would have this. Okay, over here, oh, that's it. Krista has a box of chocolate candies. The number of chocolate candies in each row form an arithmetic sequence. Write the equation. So, up by 3, up by 3, up by 3. So that means my common difference is 3. So a sub n equals 3 plus 3 times n minus 1. So 3 plus 3n minus 3. So a sub n is 3n. So I take that and I want the 9th term. So I'm going to take 3 and I'm going to multiply it by 9, which will get me 27.